Could the combined jumping power of every single cat in existence shift our planet off course? First, let's get a head count. As of now, experts estimate there are about 600 million domestic cats in the world, lounging on couches, knocking things off tables, and plotting who knows what. Add in the feral cats roaming free, as well as their larger, wilder cousins like lions, tigers, and leopards, and the global feline population likely totals around 1 billion cats. Now that we have a rough idea of how many cats we're dealing with, let's figure out their combined weight. The average house cat weighs about 10 pounds, give or take a few pounds depending on how generous they are with their exercise routine or how frequently they raid the treat jar. Big cats like lions and tigers average closer to 300 to 400 pounds each, but they make up only a tiny fraction of the total population. To simplify the math, let's stick with our billion cats, averaging 10 pounds each. That's 10 billion pounds of feline fluff, or 5 million tons. For perspective, that's about the same as 25,000 blue whales, 50,000 Statue of Liberties, or half of the Great Pyramid of Giza if the pyramid were made entirely of cats. Next, let's picture the event. Every single cat in the world gathers in one place, probably an enormous field, filled with cardboard boxes for morale, and they all jump 1 foot straight up. Here's where physics comes in. When the cats jump, they generate force. This force is equal to their combined mass. Remember, 5 million tons multiplied by the acceleration of their jump. Let's say the cats accelerate upwards at about 4 meters per second squared, a reasonable estimate for a leaping feline. The result? A total force of about 50 billion newtons. That sounds like a lot, right? It is. For comparison, the thrust of a Saturn V rocket, the kind that sent astronauts to the moon, is about 35 million newtons. So, the collective power of our billion jumping cats is equivalent to over 1,400 Saturn V rockets firing at once. But here's the problem. The Earth is incredibly massive. Its mass is 6 sextillion tons. That's a 6 followed by 21 zeros. Even if the cats manage to perfectly synchronize their jump, an impossible task, because let's face it, cats don't do anything on cue, the resulting force would be nothing more than a microscopic nudge to our planet. Okay, so the cats can't move the Earth much, but could they affect its orbit? The Earth's orbit is determined by the gravitational pull of the Sun, which is 333,000 times more massive than our planet. To shift the orbit significantly, you'd need an absurd amount of energy, on the order of 10 to the power of 25 joules. That's a number so large it makes your brain hurt. The cat's jump, by comparison, would barely move the Earth by the width of a single hydrogen atom. That's right, an atom. It's so small that even the most sensitive instruments on Earth wouldn't be able to detect the change. While the cats won't shift the orbit, they would create a cool phenomenon. When they all land, their energy would transfer back into the ground, causing a vibration. This catquake might register on seismometers, especially if all the cats jumped on one continent. But even this would be minor, probably less noticeable than a passing truck. Also, imagine the chaos that would follow. A billion cats landing at the same time would probably lead to a global chorus of angry meows, hissing, and general feline displeasure. Some might demand snacks, others would wander off to sit in a box and contemplate their life choices. So, could all the cats in the world jumping at once shift the Earth's orbit? Absolutely not. The combined force of 1 billion cats is like trying to move a freight train with a feather. It's simply no match for the mass and momentum of our planet. But don't let that discourage you. This highlights just how massive and stable the Earth really is, and it gives us an excuse to think about cats on a planetary scale, an amusing mental image, if there ever was one.